we have a problem under physics, and the problem is this: a lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, calculate the final kinetic energy after impact. Now we have about 4 options here, right? So first, this problem is related to linear momentum, right? Collision under linear momentum. And then we have 2 types of collision. We have perfectly elastic collision, and then we also have perfectly inelastic collision, right? So this problem is leaning towards perfectly inelastic collision. Now, we need to understand what perfectly inelastic collision is. Perfectly inelastic collision is when 2 objects collide together and then move as a unit, right? They collide together and then move as a unit. In perfectly elastic collision, they collide together, but they do not move as a unit. They collide and then bounce back, right? Example of perfectly elastic collision is when you bounce a ball on the ground, right? When you hit a ball on the ground, the ball bounces up to the original height where it came from. Then example of a perfectly inelastic collision is when you take a heavy stone, you lift a heavy stone and then allow it to fall. When it falls on the ground, it sticks to the ground. So the heavy stone sticks to the ground and then remains with the ground. That's an example of perfectly inelastic collision, right? Now, if you look at this problem, like I said earlier, it is a perfectly inelastic collision because they are telling us that the bullet of mass was fired into a lead block that can move freely. So when it's a common experience that when a bullet is fired into something like a block, it sticks into the block. So since it sticks into the block, it doesn't bounce back. Since it sticks into a block, since the block is also free to move, the both of them will move in the same direction. So that means that this is an inelastic collision, right? So since it's an inelastic collision, how do we solve this, right? So first thing first, remember that we are asked to calculate the final kinetic energy after impact. The final kinetic energy after impact. That means that there is an initial kinetic energy and there's also a final kinetic energy. From the question, we are only interested in the final kinetic energy after impact, right? So kinetic energy after impact will be equal to half mass times final velocity squared, right? For bullet plus half mass times final velocity squared for block, right? So this is the formula we are going to use to determine the final kinetic energy, right? Now let's figure out the quantities, the values of quantities given from the question. So we have that mass of bullet is equal to 0.05 kg, right? Mass of block is equal to 0.95 kg, right? Then we also have that the velocity of the bullet before it impacted on the block is 200 meters per second, right? So that means that we can call this velocity initial velocity. So initial velocity of bullet before hitting the block is 200 meters per second. So initial velocity in brackets u of bullet is equal to 200 meters per second, right? While the initial velocity of block is equal to 0 meters per second, right? Reason is because the block wasn't moving, right? The block was stationary until the bullet struck on it. So the block was stationary. Since it was at rest, the initial velocity will be what? 0. Now, final velocity of block and bullet after impact is not given here, right? And since it's not given, that means we have two unknowns here. We're going to have two unknowns. The first unknown is going to be the final velocity in bracket v, final velocity of bullet and block, right, after impact is unknown. Final kinetic energy is also unknown. This is the actual one we are asked to calculate. Calculate the final kinetic energy, right, after impact. That's what we are asked to calculate. But then we need the value for final velocity of both bullet and block after the impact, because after impact the both of them will have to move, right? That movement, that velocity of movement, is not given here, and we cannot be able to find the final kinetic energy after impact if we do not know this value of final velocity of both bullet and block. So to be able to determine the velocity of both bullet and block after impact, we need to use conservation of momentum, which is m times u plus m times u. Now this first m times u is for bullet, and this is for block, equal to m times v for bullet plus m times v for block, right? So this is conservation of momentum. Now from what is given here, mass of bullet is 0.05, right, times initial velocity of the bullet, which is the initial velocity of the bullet is what, 200, right, plus mass of block is 0.95, right, multiplied by initial velocity of block, which is 0, right, equal to mass of bullet, which is 0.05 times v, right? That's final velocity, which is what we are trying to determine. So this is unknown, right, plus mass of block, which is 0.95 times v, still unknown, right? So if you multiply 0.05 by 200, we are going to have 10, right? 10 plus 0.95 times 0, anything multiplied by 0 is 0. So we'll have just 10 left here, and then we'll have that 0.05 v plus 0.95 v, right? Okay, let me just make this here as v. So since the both of them are like terms, so we can add. If you add it up, we are going to have here as 1v. 0.05 v plus 0.95 v is the same thing as 1v, right? So 1v is also the same as v. So we have that v, therefore v, that's final velocity, is equal to 10 meter per second, right? 10 meter per second. So we've now determined this value, this final velocity of bullet and block, to be what? 10 meter per second. So now we have determined the value of the final velocity of both bullet and block. What we need to do is this: substitute this value of final velocity into this equation. So here we have that Ke would be equal to half mass of bullet is 0.05 times final velocity of bullet, which is 10. So we have here as 10 squared, right, plus half times mass of block, which is 0.95 times 10 squared, right? Now here E will be equal to 10 squared is 100. 100 multiplied by 0.05 is 5. 5 times 1 is 5. So we have here as 5 all over 2 plus 10 squared is 100. 100 multiplied by 0.95, that should be 95. 95 times 1 should give us 95, right? So we have 95 all over 2. right? Now, there are different ways you can use in solving this, but we are going to use this easier way, which is 5 divided by 2 should be, that should be 2.5, right? Plus 95 divided by 2 should be 47, 47.5, right? Now, we have that 2.5 plus 47.5 should give us final kinetic energy should be 50 joules. So the final kinetic energy after impact is 50 joules, right? And if you look at the option A is the correct answer, 50 joules.